Hello, everybody. Good afternoon. Do you hear me and do you see my presentation already?
I hear and see.
Yeah, good. Okay. All right. So, thank you first for inviting me to the conference. I'm also really happy to take part and to learn more about Montagu Harriers in Eastern Europe. And I'm speaking to you from Groningen in the Netherlands. And just as Almut, I've been working for the Dutch Montagu Harrier Foundation for the past years. And just recently, I have started my PhD about the interactions of birds of prey and wind turbines. And that is a collaboration with Alexandre Milan from Aix-Marseille University, who was just speaking, the University of Groningen, and the French energy company Engie. And so now I will talk about Montagu's Harriers and wind turbines. So that's a rather specific topic. And in the first place, I will present you the results from our GPS tracking study in the Netherlands from the past 10 years. And in the end, I will give you a short introduction into the new project that we will work on during the upcoming 3 years. And oops, oh yeah, how can I? Uh, oh yeah, oh yeah, like this. Okay. Okay. So as a quick introduction, I think you are all aware of the fact that wind energy has expanded strongly all over the world in the past 20 years. And at the same time, it was found that birds of prey like red kites or griffon vultures or also common buzzards may actually be quite vulnerable to collide with wind turbine blades. And and also Harriers have been found as collision victims of with wind turbines, and that includes Montagu's Harriers, but also marsh Harriers and also hen Harriers. But until now, the extent of the problem is not very well known in Harriers. And so if you want to assess the collision risk of birds with wind turbines, there are two main approaches available, and the first one is obviously to search for carcasses under the wind turbines. And the second approach is to perform systematic observations of flight behavior. And when you choose for the second approach, there are different aspects of flight behavior which become relevant. And the first one that you probably think of is the flight height of the birds. So the degree to which the flights overlap with the height range where the rotors are rotating. But there are others which are equally important, and those include the flight activity, so simply the amount of time that the birds spend in flight, and then also the degree to which the birds visit wind farm areas, and that's what I call the horizontal overlap. And then in the end, you also have avoidance behavior, which may also play a very important role. And later on, you can combine those different or information on those different aspects of flight behavior into a collision risk model, which gives you an indication about the number of collisions that are to be expected. GPS tracking is a very suitable method to obtain data on those different aspects of flight behavior, and that's because individual birds can be tracked during extended periods, and so it's easy to quantify the flight activity and also the proportion of time spent inside wind farms. But for those other two aspects, it's a bit more tricky, and therefore one solution is to apply high resolution GPS tracking, and that means that GPS positions are collected at very short intervals of only a few seconds. And with this kind of data, you can follow the movements of the birds in very great detail and also in 3 dimensions. And the main important point is that the accuracy of the data is improved very much with this higher temporal resolution, and that particularly applies to the flight heights. So with this kind of high resolution data, the flight altitude of the birds has only an error of about 3 meters. So that means that it's very much suitable to work with this data directly. Oh, and also regarding the distance of the birds to wind turbines, the high accuracy is also important, and that means that with this kind of data we are also able to quantify those two other aspects of flight behavior. And yeah, our study area for this study was the province of Groningen in the Netherlands. So that's the same area that Almuth has mainly been talking about. So that's the main breeding area of Montagu's Harriers in the Netherlands, with about 40 pairs. And in this map you see the distribution, the spatial distribution of the nest sites from the past 10 years, and also the distribution of wind farms in the area. Those are those black areas. And you see that the wind farms, so far, they are only situated on the outer fringes of the breeding population, so not in the central parts. Yeah, and we have been applying GPS loggers from the UVA-BIT system from the University of Amsterdam. So those are the same ones that Almuth has been talking about in her talk. And then maybe it's good to note that this is a rather old-fashioned system, because the data has to be downloaded with antennas in the field. And yeah, the first birds have been tagged in 2009, and for my study I have used data until 2016. And in total, we looked at 24 adult males during a total of 40 breeding seasons, with about 2,600 individual tracking days. And most importantly, we managed to collect a large amount of high resolution data. So in total, those were more than 940 hours of flights recorded in this high temporal resolution. And so I directly come to the first part of the results. So the horizontal overlap, that means the extent to which the birds visit wind farms. And here I directly show you the most extreme case of one individual Montagu's Harrier male whose nest was situated just on the edge of a larger wind farm. And this individual male spent as much as 35% of his time inside the wind farm. But of course, you can imagine that that this varies a lot between birds, depending on the situation of the nest. Indeed, it varied between 0 and this 35%. And the distance of the nest site to the wind farm was the main factor explaining this variation. And here you see the proportion of time spent inside the wind farm as an effect of the nest to wind farm distance, and for 3 different wind farms. And you see that when birds nest further away than let's say 4 kilometers, or for this other case 5 kilometers, they barely visit wind farms anymore. So to conclude, we see that Montes do visit wind farms if they breed close. And then the next part is about the vertical overlap, so the flight heights of the birds. And there we found out that, as probably all of you would expect, most of the flights were very low above the ground. So those were about 74% of flights which happened below 10 meters above ground, and only about 7% of the flights occurred at the heights where the rotors were situated. So, and if you compare this to other species of birds of prey, you see that this is indeed a very low figure. So red kites in a German study have been found to spend 25% of their time at risk heights, and white-tailed eagles even more. So in that sense, we have good news, because Monties indeed fly relatively low, and that must decrease their collision risk with wind farms compared to other species. And then the most exciting part maybe is the avoidance behavior of the Harriers towards wind turbines, and therefore we took a closer look into the high resolution flight tracks from within wind farms. And here you see one example for one bird, and we overlaid all GPS positions around wind turbines over each other, and then we obtained this kind of nice scatter plots with a whole bunch of points. Here that's split for below rotor height, so for low flights, and for at rotor height, that's high flights. And what you see here is a view from above on the wind turbine, and the red point in the middle is the wind turbine tower. And the circles represent 20-meter distance steps from the tower, and the red circle represents 40 meters, and that is the rotor radius, and that for that particular wind farm. And so when we compare those two plots, we see that the Montagu's Harriers approached the wind turbine towers very closely when they flew low. So we have quite a lot of positions also at 5 meter and 10 meter and 20 meter distance to the wind turbine tower. But when they fly higher, there is a suspicious lack of positions here at the close vicinity of the wind turbine tower. So that is a clear sign of avoidance behavior, of at least some degree of avoidance behavior. And we also quantified this avoidance, and we obtained an avoidance rate of 94.2%. So we can conclude that Monties indeed avoid wind turbines to some extent, but then the question, of course, is if this degree of avoidance is sufficient to prevent a large number of collisions. And to move further, we included our obtained information on those different aspects of flight behavior. We took it together and brought it into a collision risk model, and therefore we used the band collision risk model. And for the present state, so that means the present distribution of nest sites across the breeding area, and also the present distribution of wind farms in the area, we obtained rough estimates of 0.6 to 2 collisions of Montagu's Harrier males per year, and that's related to a population size of 40 pairs. And then we also considered a few scenarios of repowering. So that means that the old turbines are replaced with modern, larger turbines. And we looked at 2 scenarios. The first one was that those turbines were low, and that means that the rotors went closer to the ground than in the original case. And the second case was that higher turbines are used with a larger distance from the ground to the rotors. And then we found that when those low turbines are used, the number of collisions increased compared to the present state. Those were nearly twice or more than twice as much collisions. But when higher turbines were used, the number of collisions stayed approximately constant. But at the same time, there was, of course, much more energy generated with those larger turbines. And the last scenario that we were that we have considered was the construction of a new wind farm at different places inside our study area. Therefore, for that scenario, the outcome was very much dependent on the situation of the wind farm. So there were many areas which were relatively safe because not many nests are situated there, but other areas could be highly problematic. And in the very worst case, which is about here, the number of collisions could be 3 to 10 per year. So that's much more than in the present state. And for this scenario, that's rather clear that this could indeed lead to a population decline. Okay, to draw some conclusions, I think we could show the great potential of GPS tracking for collision risk assessments, but it is very important to keep in mind that high resolution sampling schemes are very important, because otherwise you have difficulties to assess the flight altitude and also avoidance behavior. And then it indeed seems that Montagu's Harriers are less collision prone than, for example, red kites, but we could also show that when wind farms are erected in the middle of a core breeding area, that could indeed have a large impact. And then we also found that the rotor height range of wind turbines has a strong effect on the collision risk. So for Montagu's Harriers, it is probably beneficial if the wind turbines are built higher. And if you are interested in more details about that study, you could have a look at our article in IBIS that was published about a year ago, and that's also available as open access on the internet. And but of course, this study left us with a couple of open questions or new questions also, because so far we have only looked at adult males, but of course it would also be important to take females and juveniles into account. And then it's of course also a big question if those results are transferable to other areas. Of course, it could be that Montes fly differently in France or in Poland, for example, compared to the Netherlands. And then the question is also if those measures that we or those possible solutions that we found for Montagu's Harriers, if those are also beneficial for other species, or if those are maybe even detrimental to other species. And to bring those questions further, we initiated a new project on this topic, and we want to expand the perspective and include different areas across Europe, but also include different species of open area raptors. So the different Harrier species, but also common buzzards, red kites, and short-toed eagles. So and by this we hope to get a better understanding of the relationship of flight behavior and wind turbine collision risk, and also to find solutions for which are beneficial for the whole raptor community. And regarding Montagu's Harriers, we are already collaborating with a couple of partners with ongoing GPS tracking projects in France and in Germany and in Sweden. But we would like to, or we would be happy if we could increase this range even more. And as I know that some of you are also working with GPS tracking in Eastern Europe, maybe there are possibilities to collaborate on the wind energy issue. Okay, then I want to thank everybody who was involved in the study, and in particular also Ben Cox, who initiated the work on Montagu's Harriers in the Netherlands. And I want to thank you for your attention, and I'm happy to answer your questions.